A good day. This video is for limits at infinity of rational function. So a rational function is a quotient of two polynomials. F of x is equal to qm x over qn x, where m and n are degrees of the two polynomials. So we have our f of x being equal to, let's say, ax to the m plus bx to the m minus 1, and then our b of x is bx to the, okay, we should have used a1, but that's fine. Let's just put z x to the n plus yx to the n minus 1 plus dot dot. It's just like a demonstration of how it should look like. For example, we have x plus 1 over x squared plus 4. This one, the highest power is 1 on top on the numerator, and the highest power on the denominator is 2. So we're going to consider cases of f of x, where we'll be changing the powers of the numerator and the denominator, and putting limits as x goes to infinity. So if m is less than n, then the limit as x approaches infinity of f of x is equal to 0. So for us to prove that, we're just going to use a particular example. We have limit as x approaches infinity for x plus 1 over x squared plus 4. So what we first do is we first divide by the highest power on the numerator and on the denominator. So we divide by the highest order. Like what I mean is, you check the polynomial on the numerator and the polynomial on the denominator, and you look for that polynomial with the highest order. So if you find that highest power, you divide everything on the function with that. So for example, here the highest power is x squared, so we're going to divide each and every term on our function with x squared. So we have x over x squared plus 1 over x squared, right? Over, on the numerator we divided everything by x squared, and on the denominator we're supposed to divide by x squared again. X squared over x squared plus 4 over x squared. Perfect. But then, like, since we say that we can distribute the limit over sum and also over division, this implies that the limit as x approaches infinity of 1 over x plus 1 over x squared, right, over the limit as x approaches infinity of 1 plus 4 over x squared. And after this, you can just distribute your limit. Since we know that the limit as x approaches infinity of 1 over x is equal to, let's just say 1 over x to the n is equal to 0. So for any power of n which is positive integer greater than 1, a positive integer greater than 1, we know that 1 over square root of n is actually equal to 0. And same applies with this one. It's just equal to 0, because it gives us 1 over infinity, which is equal to 0. So just remember this when dealing with this kind of question. So this one will just give us 0, since we can distribute limit of the sum. So this one gives us 0 plus 0 over 0 plus 0. 1 plus 0, sorry. 1 plus 0. Since this one is actually 1, the limit of a constant is just that constant. So that is what you get. So generally, if we have the order of if we have the order of the denominator being greater than the order of the numerator, usually if we stretch that limit to infinity, we'll get 0. So this one is simply equal to 0. The same applies to the second case where m is greater than n. If m is greater than n, then the limit as x approaches infinity of f of x is called plus or minus infinity. Sign depends on polynomial pmx or qnx. If they are the same, sign x gets larger. So here we're going to have the power of the numerator being greater than the power of the denominator. So the same applies. We just first look for the highest order. Look for the highest order on the numerator and denominator, which is we look for the highest order on the numerator and the highest order on the denominator. So the highest order on the numerator is x to the power of 3. So is it overly high now? Is it higher than the order on the denominator? The answer is yes. So we have to divide by x to the power of 3. So the thing is, look for the highest order on the numerator and on the denominator. So after division by x to the power of 3, you can actually see that we get this. We get 1 plus 2 over x plus 3 over x squared plus 4 over x to the power of 3 over 3 over x squared plus 5 over x to the power of 3, which is equal to 1 over 0. Because here, if we stretch our limit, we just get 1. This one will give us 2 over x. If you stretch our limit, will give us 0. 3 over x squared will give us 3 over infinity, which is equal to plus 0. And 4 over x squared will just give us 0 all over. 3 over x squared is a 0. And 5 over x to the power of 3, it's a 0 again. So we are just getting 1 over 0, which is equal to infinity. Right. So just on the NB, we have 1 over infinity is equal to 0 and 1 over 0 is equal to infinity. That is what you should know there. Then what happens now if m is equal to n? If m is equal to n, this is a case where the power of the order of the numerator is equal to the order of the denominator. By order, I mean the highest power on our polynomial. The highest power here is x to the power of 3 and the highest power is x to the power of 3 here. So the same applies to this kind of question. We have to just first divide by the highest power, the highest order. So the highest order in this case is x to the power of 3. So you say x to the power of 3 over x to the power of 3 minus 4x over x to the power of 3 plus 1 over x to the power of 3 all over 3x to the power of 3 over x to the power of 3 plus 2x over x to the power of 3 plus 7 over x to the power of 3. So you have to stretch limit as x approaches infinity. Right. So limit as x approaches infinity of that. So here, if we simplify this, you can actually see that we get 1 minus 4 over x squared. You can actually see if you cancel this one, you get x squared here. So 1 minus 4 over x squared plus 1 over x to the power of 3 over 3 plus 2 over x squared plus 7 over x to the power of 3, which is 1 minus 0 plus 0 get 3 plus 0 plus 0, which is got 1 over 3. So that is what we get. So usually if the power of the numerator is equal to the power of the denominator, usually get a constant. That is what it is. So there is this question which is you tried. I'm just gonna try one more example from our tutorial. I'm sure it will help us understand more. So what is the limit as x approaches infinity of a0 x to the m, a1 x to the m minus 1? This one is just similar to the cases we were doing. You can actually see that if m is greater than n, we'll be having the power on top being greater than the power on the bottom. So the answer generally will give us infinity according to what we just did. And if m is equal to n, we're going to have same powers here. The highest power on top will be m, the highest power on the bottom will be m. So if we divide everything will become 0, and we just get a0 over b0 for this second case. Okay, so if you need more explanation about this, just put it on the comment section. Then if m is less than n, we can just see that the power of the numerator of the denominator is actually greater than the power of the numerator, which means it will give us something like 1 over x, which is limit of 1 over x will be as x tends to infinity will be equal to 0. So that one will give us 0. So this one we expect it to be equal to infinity, this one to be equal to 0, this one to be equal to